So before I start talking about today's tutorial, I would like to talk about node voltage method, and I would like to solve a couple of problems with you first. And then we will talk about the tutorial, which is related to assignment number 3. So let us talk about this problem. Imagine we have a problem like this. So this guy is IS2, and this guy is IS3. This guy is IS1. And this resistor is 2, this resistor is 4, this resistor is 1. And what is needed for this circuit example? So I would like you to write only the nodes voltage equations. So try to solve this problem for writing the node voltage equation. How many nodes do we have? I have 4, but actually these two nodes are considered as 1. Am I right? So this is connected to the ground. Then I have this one that has voltage V1 and this one that has voltage V2. Now, I'd like to say summation of the current for each node is equal to 0. So summation I is equal to 0 for node number 1. This current plus this current plus this current plus this current is equal to 0. So I can say that V1 minus V2 over 2 plus V1 over 4 minus I is 2 plus I is 1 is equal to 0. So if you try to write that, I'll say minus I is 2 plus V1 over 4 plus V1 minus V2 divided by 2 plus I is 1 is equal to 0. So this part is representing this current. This part is representing this current. This part is representing this current. And this guy is representing the current here. I'll do the same from that side. And I will assume that all currents are leaving. So summation I is equal to 0 for node 2. I will have negative I is 1, which is this current, and negative I is 3, which is this current, and V2 minus V1 over 2, and V2 minus 0 over 1 is equal to 0. If I try to rearrange these two equations, equation 1 and equation 2, and I try to rewrite them in a more nice formatting, I will have 1 over 4 plus 1 over 2 multiplied by V1, because I have here 1 over 4 and 1 over 2. And I have negative 1 over 2 times V2, so I will have plus negative 1 over 2 multiplied by V2, and I will move I is 2 and I is 1 to the other side. So I'm going to have I is 2 minus I is 1. And if I try to rearrange this equation, like what I did here, I will have negative 1 over 2 multiplied by V1 plus 1 over 2 multiplied by V2 plus 1 over 1 multiplied by V2. So if I try to rewrite that, I'll have negative half multiplied by V1 plus 1 over 1 plus 1 over 2 multiplied by V2, and I will move those to the other side. So this guy will be equal to I is 1 plus I is 2. Any question for those equations? This one, yes, it is I is 3. Yes, because here I is 3. Thank you. Now, I could write these two equations in another formatting, in a matrix formatting. We studied that in applied linear algebra. So instead of writing them like that, I can say I have a matrix here. This matrix has negative 1 over 4 plus half, and I have negative half, and here negative half, and this guy is 1 over 1 plus half. This guy is multiplied by V1 and V2, and this guy is equal to I is 2 minus I is 1, and for this guy I have I is 1 plus I is 3. Any question for that? Yes. Negative 1. Where? Which one? This one? This one? Negative 1 over 4? Oh, this is not negative. This is positive. Probably it is. While I'm writing it, I wrote negative. Any question, guys? Okay. We are calling in electric circuits this matrix in electric circuit as conductance matrix. Do you remember what is the conductance? 1 over R, yes. And we are calling this vector as node voltage. And we are calling this guy as current entering node I. In electric circuits, if you would like to define the conductance matrix, it is 2 by 2 in our problem because I have 2 nodes. If I have 3 nodes, it is a 3 by 3. If I have 4, it's 4 by 4. So we are calling this guy as diagonal, and those are off diagonal. Am I right? So in electric circuits, we are calling the diagonal elements as summation of conductance connected to node I. Summation conductance connected to node I. This is the diagonal elements. What about the off diagonal? Off diagonal is equal to negative the conductance connected between nodes I and K. Let us go back to the circuits. This is my circuit. He is telling me that this matrix is the conductance matrix. And he is telling me that those diagonal are summation of conductance connected to node I. So imagine we are talking about the first node, which is node 1. I have 1, 2, 3, 4 branches connected to that node. How many branches of those has resistance? I have 2. He said summation of the conductance of those. The conductance of 2 is 1/2. The conductance of this guy will be 1/. So he said 1/4 plus 1/2. This is the element, the diagonal. And what about this guy? It's talking about node 2, because in the matrix it is A to 2. A11 is talking about node 1. A22 is talking about node 2. So for node 2, I have, yes, these two are connected to node 2. What is the conductance of this guy? It's 1/2. What is the conductance of this guy? Is 1/1. So I wrote here 1/1 plus 1/2. So generally speaking, any element in this matrix, if the element is AII, if it is diagonal element, summation, I'll say AII is equal to summation for the conductance connected to the node I. What about A12 or A21? He said negative conductance connected between node I and K. Imagine we are talking about A12 or A21. They are the same. So I'll talk about node 1 and node 2. What is the conductance connected between 1 and 2? It is 1/2. He said negative 1/2. So by doing that, I can write the equations in the matrix format. If you would like to do that, that's fine. And what about those? He said those are the node voltage. You are talking about node 1 and node 2. So I'm going to write V1 and V2. What about this? He said this vector is representing the currents entering node I. Imagine we are talking about 1, which is related to the first row. He said summation currents entering this guy. Which one is entering this node? Summation current sources entering that guy. So I have I is 2 entering and I is 1 is leaving. That's why he wrote I is 2 minus I is 1. What about this guy? You are talking about node 2. So node 2, summation I entering that node. So I can say I is 3 plus I is 1 because both of them are entering. So if you want to use this matrix, that's okay. You can use the matrix, but you know how. You have to know how to build this matrix. If you asked me, for most of the circuits, I don't prefer to use that because if you are talking about like 3x3 or you are not going to use matrix for solving the problem. You are going to solve 2 equations and 2 unknowns. This is, I think, it's more easier. Am I right? But if you would like to use that method, that's okay. There's another way of representing the problem. But I don't prefer it. I prefer to use the regular way for solving that problem, just in case if there is a mistake here, everything would be wrong. Right? If you studied with me in the fourth year, a course which is called Power Systems 2, we will be talking about that. But from the point of view of power system, if we have a big network, like we are talking about city, the plan for city, the transmission lines and the loads and everything and the generation. At that time, we will use the matrix because we are talking about many transmission lines. We are talking about many nodes. Actually, we are calling nodes in power system as bus bar. It's not nodes. We are calling it bus bar. It's similar to node. But at that time, we will have many nodes. We will have many transmission lines. So it's more easier to use that if you are talking about power systems. But here I'm seeing it's more easier if you would like to write the 2 equations and solve them. But as you like, I give you that method and I give you that method. Any question, guys? Yes.
How come, isn't there 4 currents like entering and exiting?
Yes, I have here this guy and this guy at that node, and I have this guy and this guy at that node. So for each node, I have two. If you try to look to this one, I have two. This guy is entering and this guy is leaving. And for this one, I have this guy is entering and this guy is entering. That's why I wrote them here. Okay. Let us talk about something else. Yes, go ahead. No. I will not ask you to use specific. What is the essential node? Yes. As you like. As you like. If you would like to use it for solving the problem, that's okay. Now, essential node. Do you remember what is the essential node? Yes. So I can say that the essential node is any node, like what I told you before, is defined as any node that has 3 or more branches connected together. And if you still remember, I told you I usually deal with the essential nodes. I'm not dealing with the a node that has 2 branches because there is no meaning to say summation of the current at that node is equal to 0 because I know I have the same current. It will not add anything. Today, I'll talk about something else which is called supernodes. Supernode is what? Imagine I have 2 different nodes, and in between I have voltage source. We are calling these 2 nodes as supernodes. So the supernode is defined as any 2 nodes and in between there is a voltage source. Example for that. Something like that. This guy is negative, positive. This is V. And I have node here and another one here. So this guy is essential node. This guy is essential node. But this guy is considered as supernodes. This is the meaning for supernodes. I have 2 nodes, and in between there is a voltage source. We are calling this guy a supernode. Just one minute, and I'll open the floor for questions. Let me complete that first. Let me give you example on why we are talking about supernodes. Let us solve problem related to node voltage method. Imagine we have circuit like this. This guy is 10 volts. This guy is 20 ohms. This is 3 ohms. This is 6 ohms. And we have here 10 ohms. This guy is 2 amps. And here we have voltage, which is 3 volts. How many nodes do we have for this circuit? How many nodes? I have 1, 2, 3, 4, 5, 6. Excellent. But actually, these two are considered as one node. So I can connect this guy to the ground. This one. Now, how many nodes left? Actually, 4. 1, 2, 3, 4. These two, can I consider them as one node? Yes. Why? Because there is nothing connected between them except wire without resistance. So I can consider as well those as one node. So how many nodes left? I have 3 actually. I have this guy, I have this guy, and this guy. Now, the question is, use node voltage methods to calculate VA. What's VA? He gave me that this voltage is VA, with respect to the ground. So, for solving, use node voltage method. The method says I have to choose one of my nodes to be reference. He was nice and he gave me the reference nodes. Then the second step, I have to define all nodes voltage with respect to the reference nodes. So this guy is defined. He gave it to me, it's VA. What about this guy? Is it defined? I have to define it. For example, I'll call it VB. What about this? Is it given? No. This guy is given? It is. It's 10. The voltage between that point and that point is 10. You forgot? So I can say the voltage for that node is equal to? Yes, the voltage for that node is 10 volts. Now I have 3 nodes. I'm going to say summation the current for each node is equal to 0. But before I start solving such a problem, I have to ask myself a very important question. Why am I using node voltage method to calculate what? I'm using node voltage method to calculate what? The voltage, right? If the voltage is given, do I need to say summation the current for that node is equal to 0? No, it's given. Unless I asked you to calculate the current here. At that time, you will say summation the current for that node is equal to 0. But since the voltage for the nodes, while I'm using node voltage methods, is given, there is no need to start solving the problem by saying summation the current here is equal to 0. I'll wait. I'll start by another node. I will not start by this node. Why? I'm going to avoid starting by saying I is equal to 0 for that node. Why? Because if you set summation the current here is equal to 0, there are one of two things you are going to do. Number one, you are going to make mistake. Why? Because what is the current here? Some of you will say, oh, the current here is equal to 10 minus 0 over, and leave it without anything, which is totally wrong. So some of you will say that 10 and will add it as if it is current. I have seen many of you in the previous years did that. 10 minus 0 and leave it plus the current, which is totally wrong. So V1 minus 0 divided by what? I don't know the internal resistance for this guy, so I couldn't say V minus 0 over. The only option, which is the second option, some of you will do, will assume the current here as I. It's unknown. So imagine you are starting solving the problem by assuming there is unknown current here, as if you are injecting extra unknown to the problem. So you are writing equation, but this equation you are adding extra unknown to your problem. Are you seeing what I'm talking about? Do you like me to repeat anything? Why I'm not saying from the beginning summation I here is equal to 0? Because the voltage is given, which is 10. If you would like to say summation the current here is equal to 0, you have to know this current. And you will assume it, which is one more unknown. And I'm trying while I'm solving the problem to avoid the number of increasing the number of unknowns. So it's better to avoid writing summation I is equal to 0 at that note unless you need it. So I will not start writing my equations by saying summation I here is equal to 0, but I will start from here. Summation I for this guy is equal to 0. So summation I is equal to 0 for node 1 or node A actually. This guy is leaving. So the current here, it is VA minus 10 over 3 plus the current in this guy, VA minus 0 over 20 plus the current in this guy. What is it? The current here, VA minus VB. Excuse me. I heard someone here saying something. No, I heard something else. I hear someone saying plus 3. No, this is voltage. That's why I would like to catch that guy to show you example. I was talking about it and I hear. Did you hear? Did you hear the guy who was saying 3? I heard someone from here saying plus 3. Anyway, so the current here, many of you will say VA minus VB over 3. Totally wrong. It's not right. How come VA minus VB over 3? 3 is voltage, is not the resistance. Some of you will write VA minus VB divided by 0. It's totally wrong. Some of you will try to be smarter and write VA minus VB. Why should I divide by resistor? Ignore it. He didn't give it to me, so I will ignore it. It's totally wrong. So I don't know this guy. I don't know its resistance, which means the current in this guy is unknown. I'm going to assume it, which is, for example, I. So plus I equals 0. This is the first equation. The second equation, summation I is equal to 0 for nodes B. I have this current, this current, this current, and this current. So this current is what? It's minus I. Plus this current is VB minus 0 over 10. Plus this current is negative 2. Plus this current is VB minus 10 over 6. So VB minus 10 over 6 equals 0. This is equation number 2. How many unknowns? How many? I need one more equation. Should I say summation the current here is equal to 0? If you said summation the current here is equal to 0, you are adding extra unknown. You are not solving the problem. You are adding one more unknown, which is the current in this guy. So what should I do? So I'm hearing someone is saying something here about the relation between VA and VB. If you try to look, this is VA and this is VB. and the voltage difference between them is 3. Which one is higher? VB is higher than VA. How did you know? Because of positive and negative sign. So I can say the difference between VB and VA is 3. Is it VB minus VA or VA minus VB? VB, which is positive, minus VA is equal to 3. So VB minus VA equals 3. At that time, I can solve these 3 equations together. But do you need to calculate I? No, because I didn't ask you to calculate it. So if you try to look to these 2 equations, I can move this guy to this side, and I can substitute from equation 2 into equation 1 by I, and write one equation. So if I try to do that, from equation 2 into 1, I will have VA minus 10 divided by 3 plus VA divided by 20 plus, instead of I will have VB over 10 plus negative 2 plus VB minus 10 over 6. This guy is equal to 0. By solving this equation, along with this equation, I can find VA and VB. I have at that time 2 equations in 2 unknowns only. I can solve these 2 equations together and find the solution. So if you try to solve these 2 equations and find the value of VA and the value of VB, you will find that VA will be equal to 10.41 volts. I think it's very easy to solve these 2 equations. Am I right? This is what we have already learned. But how many steps did I write? 1, 2, 3, 4 plus simplify. If you try to go back to the problem, oh, this guy was talking about super nodes, and he told us if I have 2 different nodes and in between there is a voltage source, I'm looking to this guy as a super node. And at that time, if you would like to solve the problem, instead of saying summation I for that node is equal to 0, summation I for that guy is equal to 0, you can say summation I is equal to 0 around the super nodes. See how to do that. Now we have super nodes. Am I right? Let us copy this guy and go down. I will copy that. And I will go down by that guy. So I'll put it here. Now, this is 10 volts. Can I do that here? Yes, I can. I have super node, which is that guy. I'll say summation the current for the super node is equal to 0 if we realized that there is a super node, then we can say summation I is equal to 0 for the super nodes. How many branches? I have this current. I have this current. I have this current. I have this current, and I have this current. Let me write all of these currents. So the first one, which is VA minus 10 over 3 plus this guy VA over 20 plus this guy VB over 10 plus this guy, which is negative 2 plus last one, which is VB minus 10 divided by 6. And by the same way, I can say VB minus VA is equal to 3. How many equations do I have? 2. In 2 steps only, compared to the previous, I wrote 4 steps. Let me see if they are the same or not. Oh, you said after modifying these 2 equations, you got VA minus 10 over 3. Yes. VA over 20. Yes. VB over 10. Yes. Negative 2. Yes. VB minus 10 over 6. Do I have the same equation? Yes. So if you realized from the beginning there is a supernode, you can say summation the count for the supernode is equal to 0 and write your equation. It will be very easy, straightforward problem. If you didn't realize that, that's okay. There is no problem at all. I'm going to solve the problem as if I have 2 different nodes, but the only thing is I'm going to assume that this count is I. And I'm going to write 2 extra equations. Which are those? But I will reach to that equation at the end. Any question for that?
Does it have to be just the voltage?
Yes, this is the definition for the supernode. It should be voltage source only. If it is a current source, it is not a supernode. If there is a current source, we are going to talk about something else for mesh. But actually, if you are talking about supernode, you have to have 2 different 2 nodes, and in between there is a voltage source. You asked me, yes? Yes. It doesn't matter. They could be essential, they could be any nodes, but like what I told you, it's better if we are talking about the nodes to talk about the essential nodes, because this will add to the problem. Someone else who is asking in the back? Okay, another one. Any other question? Okay, so this is what I would like to talk about, and then I'll talk about the tutorial right now. So this part is the part that I was supposed to cover it yesterday, but because I didn't come, so I covered it today. Now, let me save that first, and I will close it and open another file. And I will stop recording.